Yeah. All right. Hi. How about that week-long Thanksgiving break, huh? That's exciting. I've been here, this is my 13th year. We've never had that. I've always taught Mondays and Tuesdays of Thanksgiving week. So I'm not gonna say no. I can have class Monday and Tuesday if you want. Thanksgiving week, if you want. How many people want that? Oh, thanks. No, it's okay. All right, well, let's see. So we left off, we were doing double integrals. And I really want to just continue with that. Let me just remind you, I think we had done, I think most of the groups had done number one. So let me just remind us, like both ways. So, oh, let me stop this share. So, double integral problems. So number one here was the function x squared plus y. The region was bounded by the parabola y equals x squared. And the line y equals 4. It's 4, right? Yeah, so this is the region. Y-axis isn't really there, so it's not like the region's cut in half or anything. And then I think it's probably worth noting what these 2 points of intersection are. This is 2, 4. This is -2, 4, right? And if you use vertical slices, I think most of you got the vertical slices pretty easily. Although you got to be careful, right? So like, I mean, just because the setup of these is kind of interesting, it's like you always have to think about all the different possible vertical slices. And the thing I've been hammering a little bit so far is just that, like, you want to think about each slice, and you want to think about like adding up all the slices. So I know a lot of you will jump immediately to the just writing the integrals down, but it's sort of like nice to think about like the bottom of the top of each slice, and then the leftmost and the rightmost slice. This is often how I write things down if I'm not sure. So what's the bottom of each slice here? All the bottoms of the slices are y equals x squared, right? So that's the whole thing where that you can have a variable now. The slices themselves are variable, but the top's not variable, right? Top always lands at height 4. Top always stops at height 4. The leftmost slice, what's the leftmost slice? X equals -2. Yeah, so there's slices all the way from -2 to 2. And then you just write it down. So the integral of the whole thing, again, some books put a double integral here, which I kind of like, but our book doesn't, so I'll just go with our book. So, you know, the inside integral is the each slice integral. And you don't want variables on the outside anyways. Like if you put the y equals x squared out here, that would mean you'd end up with an x in your final answer. But your final answer is supposed to be a number because it's a volume, right? And then this is dy to match this. Again, if you look in the book, they kind of drop a lot of these. But I guess you can infer from the d. Like since this is a dy, the books often won't say y equals, but you can sort of say, okay, well, x squared to 4, it's got to be y. Like that, right? Good. Should we evaluate this? Do you want to? I see one no, and I see one vigorous no and one vigorous yes. I got a no and a yes again. It's all coming in pairs. It's some number. I mean, the only reason I would want to maybe evaluate it is just to see that you get the same thing with horizontal slices. But let's we can move on. So let's just say with horizontal slices how this would work. Because you can evaluate this and get some number, you might check. But horizontal slices, whenever I look down, I always get written in the microphone. Let's see, here's horizontal slices. So horizontal slices look like this, right? And now there's a little bit of an extra thing here, because now we're going from x equals to x equals. Here, the bottom, the bottom here was a y equals x squared. So y equals 4. But now if I'm going to go left to right, I need an x equals here and an x equals here. And so what does x equal in each of those cases? It's plus or minus root y, right? Because that's the thing here. This means if we solve for x, we get plus or minus root y, right? And, so this is the positive square root over here, and this is the negative square root. So this is plus root y over here. This is minus root y over there. Okay, so if you do the same thought process, each slice you have the left sort of endpoint and the right endpoint. I don't know why I didn't feel the need to say endpoint for bottom and top, but I do feel the need to say it for left and right. I'm not sure why. It's sort of slight difference. And then you add up the slices, so then you'll have the bottommost slice. Because they're horizontal, you have the bottommost and the topmost slice, right? So we just said the left endpoint of the slice is x equals negative root y. The right endpoint is positive root y. The bottommost slice, if we take all those horizontal slices, 0. And then they go all the way up to number, please. Thank you. Someone say number for me to write. Okay. And then there you go. So then if we write this out, that's an R. Then, yeah, x is negative root y, x is positive root y, x squared plus y. Now notice this starts dx. Y equals 0 to y equals 4. And then that's dy. So that one was dy dx, this one was dx dy. But I don't necessarily, I mean, you could try to remember that. Vertical slices is dy dx, horizontal slices is dx dy, but when you do the setup, you sort of see how it works. Okay. Does that all make sense? Did anyone evaluate both of these and get the same answer? Yeah, you did. Yes. If you evaluate them, you should get the same answer. Yeah. Okay. Well, yeah. Anyways, a lot of times actually on tests and stuff, I'll just say like set up but do not evaluate, because I don't even. Yeah. It's not even I mean, the thing is often not the actual integral. It's more like sometimes I'll just put like a generic function f in here and then just say set up and evaluate. By the way, if you wanted an area of a region, you could just put the function 1 in here. That would give you the area of the region. Is that believable? Because it's like you've made a cake now where the bottom is the region and it's height 1. So the volume of the cake is the base times 1. which is the area of the region. So actually, you could actually think of all areas as double integrals if you wanted to. In fact, we're going to talk about that later. But and you can also see here that like if you actually put the function 1 right here, that they would integrate to just give you y. And then when you plug in the endpoints, you get 4 minus x squared. So you'd be integrating 4 minus x squared from -2 to 2, which is what, if you wanted the area of this region, you would do the top minus the bottom from the, from the intersection points, between the intersection points. Yeah, Caleb. Yeah, we're going to talk about triple integrals. We're going to talk about regions in space. We'll start with rectangular regions in space, which are easy, but then we're going to have weird blobs in space that we're going to try to integrate some function of 3 variables over. It's going to be fun. Yeah, sounds fun, right? Okay, so anyways, these are the 2 answers to that. I just want to make sure we're on the same page. But then for the rest of class, I just wanted us to keep going with these problems, because I think maybe some of you had started to get into problem 2. But there's more problems here. So yeah, and there's different wrinkles I throw into some of them. 2, I say use vertical slices and then repeat using horizontal slices, but there's an extra bit of difficulty. And then sometimes you'll get an easier integral if you set it up like horizontally or vertically. I can go backwards and give you the integral and say describe the region. Notice I didn't put y equals or x equals here. I just sort of see how big I can make that. There you go. This really means y because of the dy here. This means y equals and y equals. Also, there's an x there, so you wouldn't have x equals x over 2, but and then the dx here is x equals 0 to x equals 2. So you can go backwards and go from an integral to try to find the region. It's an interesting kind of question. Yeah, so should we continue group work? I don't know exactly if all the same people were here on, but if not, just join a group. Just make the same groups you were in on Wednesday, and then join a group if you weren't here on Wednesday. Let's do it. Let's do problems. Where fun is. I'm gonna pause the recording.